So let me, by the way, I just want to make sure that you all get blockchain, right? We don't have to discuss what it is. And this will take a few minutes. But the question here was, in the layering system, where does Polkadot reside? So Polkadot, Gavin Wood was the original guy that came in from Ethereum, and he was building Ethereum, and then he went in with Polkadot. And then you have other projects like Cosmos and VonChain, and there's another guy called Aeon Foundation, which is, I think it just came to India as well, some of the founders that I know really well. So in most cases, these are basics of, I'm sure somebody from IBM must have done this before. This is asset we created, I think one of our colleagues here. So the idea here is two things, right? And I'll discuss the Polkadot in a minute, but this is the distinction between permissionless type elements, because we will touch by the end of today the use cases and why that matters for what is permission, what's not. This example that we gave before some of you guys came is, if for you to own a security from the US markets, it's not easy. You have all kinds of intermediaries in between, and you cannot just put 100 rupees or $100 into it. You need to have a sizable chunk to be able to own any security in foreign markets to take advantage of economic growth. And so you have this point-to-point element. But this is also true for supply chain. It's also true for trade finance. When you move a container from a freight forwarder, or let's say you're shipping mangoes, which is pride of India in general, to, let's say, someplace in the United States, the farmers end up going to freight forwarders who containerize this whole thing. Then they go to a shipping company that they have to ship this. There's a whole kind of handoff that happens along the way. Well, mangoes is different, but you could have other elements where people could actually alter and change some of those elements. So this is the same process, except that when you move those things, there's a business process management element to say when a container comes in, or when you provide a document that says this is a container that contains full of, somebody has to verify it, somebody has to accept it, somebody has to sign for it. And then those documents become sort of the paper trail. And when you move the container to a shipping company, they have their own process to make sure that nobody is accusing them of wrongdoing or anything else. So they have their own business process. So right now, the business process which is what Amazon has simplified as a single portal and obfuscated all that complexity from you, is having all the business processes running in the individual. And the reason why it takes so much time for traditional way to move things, because every company has their own business process. So when you move an asset from A to B, or try to move international money from India to US or US to India, it takes 6-7 days sometimes, with the exception of some other new forms like Zoom and all that. We can discuss how they do it. And the idea there is that in blockchain in general, or digital assets, especially in permission world, and which is what we started our journey with Hyperledger Fabric, is flattening that business process. Because I have enough visibility of what other team has done or other party has done, I'm able to then trigger my business process and not wait for the paperwork to come to me to start a new business process again. And fundamentally, there's something that you should learn, which I have taken 8 years to distill it down, is if blockchain solves something, it's time and trust. You're solving the time that it takes to move information across multiple channels, multiple participants. And time actually has a lot of implication on money, because opacity of information over time leads to corruption, leads to fraud. So suddenly now you have 2 days of no opacity of what transactions are happening, whether it's a bank or counterparty. The good old Harshit Mehta case, if you remember that's all about time. That there was gap between information realization, and that people begin to take advantage of that gap until things went wrong, right? And trust is, you trust your bank. Hopefully you trust your bank. And banks take advantage of that trust in element. 1 minute, Niharika. And so in this case, if blockchain solves for two things, so when you're looking at why, somebody asked me, why use blockchain? Who was that? Somebody asked me. Akshat. You know him?
Yeah.
Okay. Okay. So Akshat, you asked me why use blockchain. I always look this as a litmus test. Am I only solving for time? I can use enough compute capacity and speed up the batch processes and everything else. And I have enough compute again to solve for trust, but it has to be both. And one more thing that blockchain has tenets is trade, trust, and ownership. So the reason why I founded Digital Asset Labs after Blockchain Labs and IBM is almost after 2 or 3 years, we start selling databases under the guise of blockchain. And we are like, this is not why we came, this is not why we're doing blockchain. And so you need to have some tenets that you need to have a digital asset, you need to have a tokenized assets, you need to have element of trade, trust, and ownership in movement of the asset. You have to trade something, you have to solve the issue of trust, which is the intermediation and disintermediation, and you have to have some sense of ownership, whether it's individual, whether it's in case of NFTs, a company, a marketing entities, and eventually disseminating this whole element of tokens. And somebody has to own it at some point. That includes your own treasury from that perspective. So those are the two things I would take away at a high level, that if you're looking at a lens, why blockchain is a question that should come all the time. Like, why are you using blockchain? Those are the things that I would look at a high level litmus test and then tease out. You had a question?
Yeah, so my question was related to the trust factor. So when you talk about permission and permissionless blockchain, so in the permission blockchains, you have a set of parties which they participate in the consensus and they are the ones who are taking the decisions. So then how does, the trust factor really comes out in the permission?
Yeah, no, that's a great question. Two things, right? One is most public blockchain networks, most truly decentralized systems are trustless systems. That doesn't mean it lacks trust. It means that you are relying on a counterparty to give you the trust. Like a bank is a counterparty, right? I don't know if you know, finance people may know this, but you know fractional reserve model? So when you deposit 1 rupee in a bank, they turn around and lend 10, that's the business model essentially, right? So by providing a trustless system, you are inducing trust in the protocol. So the lowest layer of blockchain is consensus. So any blockchain in the world has 4 components. It has a database of some sorts. So we are using the same tech that has been going on. You have cryptography, and this is 30 years old, by the way. You have smart contracts, and anybody for the 4th one? Consensus, which is agreement. All these technologies have existed for 30 plus years. We've had databases for the longest time. Where the form factor has changed from relational to NoSQL to object-oriented, and now you have different versions of NoSQL database. And we are using the same databases in most blockchain. It may be a Cassandra, LevelDB, and other databases that are emerging that have certain specialized properties. Cryptography has been there since epoch. We always have tried to cryptography, in technical terms, it's been there for 30 plus years. We've had encryption, we've had some elements, and encryption has advanced based on availability of compute capacity, so it becomes harder and harder. And historically, what we've done is we've increased the key length because it takes longer, but now we have enough compute capacity. So we move to elliptical curve, which has a curve-like mechanism. So mathematical models have changed the way we have treated cryptography. And then you have smart contracts, which gives you business logic, and you have consensus, which is the foundational layer that provides the trustless mechanism. This is how we agree on transaction finality, how we agree that transaction actually happened between Nitin and Niharika, for example. So, and any blockchain, there are 200 layer 1 protocols, by the way. A dozen are dominant. The remaining are aspiring to be there, and some of them are defunct. But they all have 4 of these components. And the idea is that if I use a trustless system, the trust is provided by protocols, which is the mathematical model of how we ascertain things have happened. And then you solve this issue without paying the massive fee structure that today we have to pay for all the trust intermediaries that are in the system. 1 minute. And then the other one is the consortium model. This is where permission blockchain comes. So in this case, because it's permissionless, anybody can join, anybody can have a node, anybody can be a wallet, anybody can choose to participate in an economic system, whether the economic system is having a node, having mining, having a wallet, some way or the other. You don't need anybody's permission to do it. And that's essentially when quasi-decentralized systems, which is what we call permission system, this is the biggest flaw in my opinion, and love to get your perspective because you have been working on this. I have spent first 6 years of my life building Fabric, and then I moved away from it for some reasons. It's still a valid thing, but the question is they're trying to use DLT and blockchain, and I distinguish between the two. And so I don't use the word interchangeably. The industry does. I distinguish between what a distributed ledger is and what blockchain is. There are 2 different things in my eyes. But the question they should be asking is, they're trying to adopt the same technology to remove trust, having a trustless system, but with a governance mechanism. So how does that work? You're building a system that is supposed to give you the trust with consensus and build a trustless system, but then you have a system admin who has all admin capabilities, who has passwords, who can revoke a certificate, who can issue a certificate. So the question then became can these two systems coexist? Okay, and this is my personal journey of almost a decade, where I spent the first 4 or 5 years in going to all consortium ACHs, including the RBI in India, is saying that fine, they cannot use permissionless model because no one understands this, no one who's managing it, and every country, including India, has a law of system resiliency, which means that your payment systems have to be up. If they're down, they have to inform RBI because that has a massive impact on the economic system. So in this model, they want to create this, but none of the quasi-permission decentralized model have a token framework. So how do you decide how much compute capacity you want to give this infrastructure for you to process your transactions? How do you hold people accountable if you're expecting a Fed bank and RBI and Axis Bank and all these guys to bring their nodes? So then they said, it's impossible to have that model, the incentive infrastructure. So let me have a centralized entity, which today we have, the ACH, the automatic clearing houses, which we can build this network. So I don't know how many have heard of India called BIC, entity called BIC, Blockchain Infrastructure Company. Have you heard of it? So 14 big banks in India got together 2 years back and formed this formula. They haven't done anything yet, but they formed this entity. It's all public information, by the way. And they want to build this infrastructure which allows for using DLT. But fundamental element of DLT is missing the trilemma that Shreyas, if I say your name right, Shreyas mentioned that you have the trilemma of decentralization, security, and scale. So that is the dichotomy that we're trying to solve. And I came to the conclusion, and I built this just to prove it, something called Worldwide, which we couldn't go business because that would make IBM a financial services, where we said you have a model which is a global blockchain network. And I know you're going to ask me how it's different from the sidechain business. If I can create a layer on top which uses blockchain as a utility for transaction finality, and I can do all the things of onboarding, issuing a wallet address, and issuing all these things, and still use a public blockchain. So I call this a private-public model, just like what we have done with internet. So you have intranet, which is a VPN-based structure, which allows people from globally dispersed organizations to communicate with each other, with security. Can I not do the same thing for a model which still utilizes the public utility, because the cost of doing this is, get this, 70% less than if you were to build this from scratch, which is most of the DLT projects in the permission world or permission world is from the scratch. You have to form a whole new entity. It becomes a software development nightmare, and that's what we're getting away from. I'll pause. I know you had a question. Any comments from you, because you work in that, and does it answer your question?
It might be a stupid question, but I just want to understand.
So I'm going to say the same proverbial thing. There's no such thing as stupid question, which everybody should say that, but go ahead. But there are, by the way.
Basically, blockchain, while it solves for time and trust, but what about anonymity? Like you mentioned about CTF, right? So, that's the reason why I think it would probably not replace the traditional.
Anonymity does not mean it can't be trusted. So I don't want to confuse the constructs of identification and cryptography and like you're trying to induce trusted protocol, which means the protocol can still either be anonymous, be pseudonymous, or remove the element of anonymity because it hinders societal growth, for example. So I don't think anonymity as a conceptual element has anything to do with trust. I can still obfuscate your information, which we do in traditional banking. I shouldn't be able to call your bank and say, hey, what's happening with this guy's account? They're like, who the hell are you, and why do you want to know about this guy? I can still keep you pseudonymous from that perspective, right?
It depends on the definition of trust.
No, it depends on, to me, trust and anonymity is orthogonal.
But like in a traditional system, you have an oversight mechanism.
Yeah.
So how does an oversight mechanism work?
Yeah, another great question. So to me, all the ZK families, so zero knowledge is a family of, so it's not one technology, it's a family of zero knowledge, ZK Snark, ZK Stark, you have all these different technologies. They are, that's right, knowledge proofs are meant to solve anonymity while preserving the trust system. So all the layer 2 protocols are doing the same thing to say, hey, or Monero, for example, or which is the crypto guys, which is the Zcash. they're all trying to solve the same issue. They say, because Bitcoin is pseudonymous, I can always resolve. So they're saying, can we completely introduce anonymity? And that's where they actually cross paths with the law. So the interesting thing about this piece, from blockchain perspective, is everybody wants transparency, right? Because transparent markets attracts capital. Transparency lets people to do less fraud because everybody knows everything else. But while the regulators and the law enforcers want transparency, they also want less anonymity. Well, you can't have your cake and eat it too. Well, that's the whole reason why you have cake, when you want to eat it too. But the point is that you have these two systems that are colliding, where we all want transparency, but still want to protect ourselves, and law enforcement says that that's a problem. And law also tells you, for BSA, the Bank Secrecy Act, which has a different flavors in every country, is I want to preserve your privacy. So privacy preservation and anonymity are two different things also. Does that make sense? It's a little convoluted, but they're in opposite path to solve the issue.
I understood that. Like you said, like law and blockchain when they collide. So how exactly is that getting solved?
Yeah. So I think, to me, to solve that is, I mean, if I had a silver bullet, I would be doing that. I wouldn't be spending 2 days here. But my point is that my work that has gone into this, our team's work and the industry's work, has looked into monitoring as a primary foundation. Like you have to, like most regulators, we ask regulators to have a node on these systems, have a node on Solana, Cardano, and the layer 1 protocol, so you understand the transaction patterns. Having a monitoring framework gives you better insights. Instead of fighting the privacy preservation or whatever, you can let people, so for example, if I want to have a private transaction with you, I can still do that today with cash. No one has to ever know. That is happening. So the question is, when I go to that level of anonymity, then every transaction you do with cash has to be peer-to-peer. Havala is a peer-to-peer system. It's an extended peer-to-peer system, right? So we are saying that you need to have a right monitoring framework, and people who want to take advantage of speed, agilities, communication, they will have no choice but to give some elements of anonymity to take advantage of global networks, right? So if you're in Vietnam and you're here, you won't like to know who you're dealing with. So you have to give some elements. So there's a whole notion of what we call as fractal visibility, or partially homomorphic and partially homomorphic encryption, where we're giving you some partial elements of what you need to know. And that spills into some of the elements of digital identity and self-sovereign identity and verifiable claims to say, how do I believe you're saying who you are? Yes or no? No, zero knowledge proof is just a layer which obfuscates information. So you have an entire system. So for example, to your question, right, how is identity? I can take identity as an NFT, and I can go through the same process of blockchain to be able to take identity and pass it on to you. But you can query the blockchain with simple element of, if I'm going to a bar and buying alcohol, or buy one get one free option, then am I not having a element of is Nitin 21 and above? I shouldn't have to give my address, my information. So that's verifiable claims. And all zero knowledge does is zero knowledge lets you transact with you without knowing everything about you, but knowing that you exist and you are who you say you are. Does that make sense? Somebody else? Yes, your opinion on permissionless.
Yeah, so I think permission both have necessity, and what permission is doing is grouping the public into like smaller centralized nodes. And both of them are required, so with Fabric I had my own issues with the certification authority, which is when we moved to INVI. So Hyperledger INVI provided a great mechanism, but again has its shortcomings. So if we can implement something like INVI on a public blockchain, I think that will solve for it. Introduction of IPFS actually confused me a bit, because again, so
IPFS we should do in Web3. It's very much a Web3 thing. IPFS is an interplanetary file system. I'll explain what that is. But you're absolutely right. But India and Fabric are not interoperable.
Yeah.
So this is where things become interesting, where, and this is why I got this slide. And thanks to Karan for your Polkadot. I don't know if you're getting bored with this, but you brought Polkadot question that opened this whole can of worms. I think it's important for you to understand this. Is you have Ripple, Ethereum, Bitcoin, and you have all these things which you have in parallel. There's about a handful of well-known projects, but there are a few hundreds who are incubating in some corner of the world, trying to solve the trilemma and security and zero knowledge proof and everything else. What we're expecting is having an application, which is layer 4 protocol, as we learned in the last session, having a business domain, this is layer 3 protocol, solving for a problem, and then you have all this clunk of tech, decentralized, half decentralized, quasi, or permission networks, and somebody has their own raft, proof of work, BFT, and this is where IPFS comes into play. The lowest layer, which is the Web 3.0 layer, is decentralizing storage in general. Because, when you go to Web 3, we'll realize why this layer is important. So Polkadot by Gavin Wood he claims to have Polkadot as layer 0, which is below layer 1, below layer Ethereum and Bitcoin. I'm viewing Polkadot, and it doesn't really matter what I think. It's Gavin, it's his project. He defines what it is, and it is what it is, as a trust intermediary. So if you look at this picture, you have Ethereum, you have Bitcoin, you have Solana. For the asset to move, it's impossible. It doesn't happen because of cryptography, the verification, validation, the consensus mechanism, not to mention the technical difficulties of what is an asset definition and so on and so forth. All the things we learned this morning, sorry guys, you missed it, so you should feel bad. I'm just joking, but all the things we did in the morning, right? So the question is, what happens here? Just like when we move money from an Indian financial system to US financial system to a Brazilian financial system, it goes through intermediaries. At some point, central bank is involved, but you have FX, Forex, and for money exchange, and you have investment banks who are involved in moving your assets. In protocol world, we are using a bunch of technologies called HTLCs, hash time lock contracts, or bridging protocols, or like you must have heard of the wormhole challenge that we've had with Solana and Jump Capital. If you haven't heard of that, basically it's a mechanism to lock an asset in one network and create an asset, because main thing is verification validation, and that has to happen for every single transaction, every single asset. So Polkadot, for many of you don't know, provides a mechanism to say, I will sit somewhere here, or I'll sit between all these chains. Bad thing. I'll sit between these things, all the different chains, and I will manage this orchestration of movement of assets. So to me, Polkadot becomes a trust intermediary because all they're doing is locking and issuing an asset, and they have their own token, which gives you the ability to say, I need so many dots for this asset, and they'll translate the dots, and they're able to then do something with Ethereum, whether they want to move Ethereum to a different network and so on and so forth. They're calling themselves layer 0 because they say that, so this is trust intermediary, which is what you see in this picture here, but their claim to why they call it layer 0 is they put Polkadot at the very bottom of the stack, and they expect Ethereum and all these guys to sit here. So they want to be the default operating system of asset transfer around the world. Just a different way of looking at it. But there's not going to be one chain that's going to rule the world. There will be multiple chains. The question to me, I'm going to go with this because my belief system, I can do whatever I want to do with my belief system. But I think that they're a trust intermediary than a layer 0. To me, layer 0, to your point, is something like IPFS. All the Web 3.0 technologies are layer 0 technologies, in my opinion. You raise your hand, right?
I just have one more question.
Go for it.
So basically, I want to understand how will information migrate from one blockchain to another blockchain? Like, how does that happen?
Yeah. No, that's a can of worms, but I'll try to explain that. So two things, right? So if you look at typical processing in a blockchain network, there is an asset, there is nonce, there is from and to asset, there's an asset definition, whether it's you're going with account-based or token-based model. Token-based is using Merkle trees. You have some information organization mechanism that allows you to split assets. And you go into this mechanism of blockchains, the next block gets created, they go through entire verification of all the previous blocks, create a commitment of transactions. So let's say Ethereum is using proof of work or modified proof of work. They're using, let's say, level DB, and they're using a few other technologies that are in this place. At the end of the day, it is still going back to the information theory. We are still using internet to do all this. So it's still bits and bytes being moved, between the networks. Let's say I want to move this to Solana, which is delegated proof of stake, may use a different cryptography, Edwards 2115, which is not used by this. So they're using different artifacts for cryptography. They're using different keys. They're using different algorithms. They're using everything different. So a asset or a block cannot move here. Why? Why cannot not move a block, just a block, which has the commitment of last add? All I'm interested in is the last transaction, right? I'm not interested in the entire chain. That could be 270,000 blocks like in Bitcoin. Why can I not move this block here? Yes, because it doesn't know anything about that block. It doesn't have the technical details. It doesn't have the other element. And in that point, why do I need another blockchain anyway? If I have to move the entire block. And by moving one block, the premise of blockchain is verification validation. So moving the one block, I have to go back verification validation, which is computationally enormously expensive. And not only that, but if I just move this one block, and in future I add blocks, so remember consistency issue, right? I have to then verify on this chain and this chain. And that's computationally impossible. So what happens in that case is we take an asset, we take the last commitment block, and we take your wallet address or whatever. We lock it to say, yes, Nitin owns, sorry, I forgot your name again, Tushar. Tushar owns this asset. And this asset is here. I'm going to take this asset and create this. I'm going to create a wallet, may or may not be owned by Tushar. If I go through a third party, the third party will give you the guarantees. And I'm going to create an asset equivalent of this here. I'm just creating a token. Think of it as an NP token. And it'll then embody all the characteristics of what that asset is. Now, when we do this through a technical layer, all this is doing is it's oblivious of what's inside of that value. It's taking a token, creating an equivalent value of this token to say these two are linked. Which means you can move this around here, you can do whatever the hell you want to do with this. But this can only be active, this asset can be active in only one chain at one point. So if you want to bring it back to this, then you have to bring it back here, lock it here, and open it here so this asset can move this chain. That's one approach. Second approach is having an intermediary, like Polkadot, Cosmos, OneChain, Aeon, some of those. And they basically do the intermediation for you. And because they're intermediary, they will do what? Charge a fee. So that's their function, that they will just say, okay, this is the asset, and I know how much Ethereum is worth, but you're moving Ethereum to Solana, so I will do the asset pair trading, and I will, for 1 ETH, I'll create 34 Solanas. So you will lock an asset, and you'll create 34 Solanas here, and start transacting here. So if you want to bring it back, and you only have 28 Solanas, then it'll give you 28 Solanas worth of Ether, minus the fees, when you come back to your full chain.
So if there are more blockchains, then there'll be more fees, right? There'll be more.
Yeah, of course. So it's like this. If you take $100 and you convert the $100 into rupees and Brazilian reais and Argentinian pesos, and at some point you'll have nothing left because it'll be all fees will chew into it.
Why are there so many blockchains fundamentally?
Everybody wants to make money. It's a race. So going back to the networking days, and I think you guys are all way too young for this, but we used to have, token ring, SNA, Ethernet. We had all the race for this, but eventually Ethernet won. Ethernet is the least secure protocol, by the way, as we all have known, hacking and all that. So if you had SNA, it was impossible to hack those systems. In fact, even today, $20 trillion worth of banking software runs on SNA. This is all mainframe technology. Not that I'm professing mainframe because I work for IBM, but generally that technology was more secure because you cannot penetrate into those sort of systems in general. So what ends up happening in that case is that Ethernet, sorry, you get confused. So Ethernet was easy, scalable, fast, and we didn't need to know about anything else because it had a decoupled layering between the MAC addresses and what address you get when you go to a coffee shop. So that was a advantage that it had. The question is, everybody's trying the best at this to see which is, again, the trilemma. What knobs can I turn to have the best scalability, security, and other elements that I can become? And if that layer one wins, as you may have seen, many crypto billionaires have been created because of just an idea. So as to how do you solve that? Whether they are cryptologists or whether they're mathematicians, and that's why I think that crypto, like a nation state status, is attracting the best minds to say, can I not do this? That's why you have so many layer ones, because they're all trying to solve for the trilemma, which is exception. What is trilemma? That's 4, not trilemma. It's quadrilemma. What's trilemma? Decentralization, right? And security. Yeah. It's a desirable property. It's impossible, physically impossible. From laws of physics, it's impossible to get all 3. You cannot get all 3. The question is, what is the best acceptable medium? Which means, can I give up on security to achieve speed?
One question. Why does the general token even need decentralization? Like, what is the need of it?
Yeah, no. I think decentralized, one, you're building a global system. So if Ethereum was not decentralized, you could not have all the NFT projects, all the other projects that you see today in existence. Because suddenly now, in pandemic, a company in Vietnam wakes up and they build play-to-earn model because Ethereum is global. If they had a server, this is a Web 3.0 conversation, by the way. If they had a server and some farm and like centralized server, do you think they would be able to achieve the global scale they have today? No. Because suddenly now you're participating, you're letting people in entire globe, because of decentralization, to participate in the economic system, which otherwise they wouldn't. Because now you're dealing with some centralized party issuing tokens, and like, who the hell is Vietnam? Why do you want to trust them? But they're tied into the trust system of the layer 1 protocol, which is backed by the trustless models and the fact that no matter what happens, I'll be able to convert my Axie to ETH. That's why.
So the currency which RBI is suggesting, it's not really blockchain, it's decentralized ledger, right?
Yes, that's a lot of question there. They picked 2 technologies, I think. And most central banks are going after DLT, decentralized ledger tech. And does anybody want to venture a guess into what's the difference between at least how I differentiate it, between decentralized ledger and blockchain?
So this is one organization that's basically verifying and validating all the transactions.
Right, you can have a DLT without consensus. You can have a DLT because all that it's doing is distributing a ledger. So most central banks, what is their function? The economic function is to reduce, to keep inflation in check and to have employment in progress, which means there are 2 primary functions of most central banks: to keep employment up and healthy and to reduce inflation. But they also do monetary fiscal policies and monetary policies, the economics and the money supplies equation of how it works. So they're supposed to control velocity, they're supposed to control supply, they're supposed to control demand. And that's why interest rates come into play from that perspective. So DLT is basically all the big banks have a master ledger with central banks. And central banks' function is to either disseminate money or remove money from the system. And they don't need to deal with me, you, and everybody else. They simply deal with the banks. And DLT makes the distributed ledger element make sense because they have, instead of them relying upon bank to report the end-of-day liquidity, they have exact visibility of all the liquidity because decentralized ledgers make it possible. But the downside of that, Akshat, right? The downside of that is that because it's decentralized, and I designed like 19 CBDC projects back in the day, that you don't want Axis Bank to know Fed Bank's end-of-day liquidity. Because if they're running a bit low, that becomes an acquisition target. So the banks take over each other or they can do interest, they can bombard them with payments and take over the bank because they're not inability for them to handle, which means that it'll trigger an event where those banks will have to ask central banks for more money because it's insured and it's nationalized banks. Yes, so that's what we do. Like, even though it's DLT supposed to be shared ledger, we have to, going back to, I'll get to Tushar. Going back to the question is, can I use privacy preserving technology that only central banks has visibility to all? And so in the past, I've applied in Hyperledger Fabric channels mechanism, which is basically payment channels between 2 banks, and having a super channel which allowed banks to be able to look at everybody's visibility. But that becomes a problem from scalability perspective. Or we can use something like ZKP, where banks can trade with each other from payment perspective, but central bank has the keys, like fully homomorphic encryption keys, to understand the liquidity of each bank. Yeah, gossip protocol is just chat protocol. It's a communication protocol that says this happened, the state is active. So
One-on-one transactions are also isolated.
that's right. So whether you're going after a single state channel or multi-party channel or one channel that has all the parties by default, you're still using gossip protocol as a communication mechanism to basically either indicate a heartbeat or state information about what's the state of ledger on every machine or every node in system. By the way, node is a very confusing term in blockchain. Everything is a node, and it can get messy if you get into the weeds of the word node. Does that answer your question? Okay, good. So this is one thing. So your Polkadot question opened the whole new can of worms, but hopefully it is beneficial to understand where this is heading, because all this becomes really important from financial services perspective, including NFTs, because if you haven't learned about Wormhole, you should, because Wormhole was founded, and there are many projects like Poly Network, not to be confused with Polygon, and there were these hack, to Tushar's point, is all I need to do is hack one of the bridges, and I have access to all their assets. And that's what has happened with Wormhole and some of these technologies, where they have become enormously expensive to be stolen and everything else.